Hi, it's Eric again, and this is part two of what is time. And I did forget to mention a couple of things, and one of them was in again going back to the interview with Jordan Peterson and um, Sir uh, Roger Penrose. And Jordan Peterson asks, like, this a very interesting question, and it's a question that basically, um, I think, uh, it's not too well. It is somewhat complicated, maybe not too complicated, but he asks, like, the question, like, when you have a singularity in a black hole, um, and you have different black holes with their singularities, are they all one singularity? And I thought that was a really good question. And Sir Roger Penrose says, no, they're all different singularities. And I was like, hmm. Just it was just another peculiar answer, and I think I differ on that too. It I think it depends on the type of black hole, perhaps. But if there's a singularity occurring, then basically, yeah, I think due to the law of gravity, which is universal, again, the singularities uh, are the same for every black hole. And um, yeah, it's complicated, but I think when you have the singularity, depending on the type of black hole, perhaps, they lead to the same place, and it's the same place where there is no time. It's just everything is just getting smashed together and just turned into this potential energy or energy, raw energy, in the most tiniest form that you could find in the universe, which is yet to be detected, and it comes out through the white holes, as I said in one of my previous videos. And I wanted to also point out this interesting article in the same scientist book that I have. Um, Measurement of time has become a finer and finer process through the centuries. An early way of telling time was by observing the position of the sun in the sky. Sundials appearing about 1500 BC made possible more exact division of the day into hours. Galileo's discovery of constant time span of the pendulum swing led to the development of far more accurate timepieces in the 17th century than had existed before. Ammonia clocks, first devised in 1948, tell time by vibrations within the ammonia molecule. When a radio wave of the correct frequency stimulates the molecule, a single nitrogen atom, pink dots, vibrates back and forth through a plane created by three hydrogen atoms, white dots. Its vibrations are so regular, variations may amount to only 1 second in 3,000 years. That's utterly, like, mind-blowing how accurate these I guess they're called atomic clocks. And just and basically, the point to point this out is that hydrogen atoms, they're everywhere in the universe, and it's the fundamental matter that turned into more complex matters, according to the physicists. And so basically, yeah, that's why I was saying, like, I think it is, depending on the type of black hole, though the singularity aspect of it probably is one singularity, and it's going into this place where it just has no time, and it's creating or crushing everything into these uh, fine particles, quantum particles, that we have yet to detect. And I think some of them we can detect, of course, because some of these black holes spew out like crazy amounts of gamma radiation from the center, from the it just from the mouth. It just has this blast of uh, radiation, and then also, oh yes, I wanted to speak about these gravitational wave detectors. So if we're not living in one universal time, well then how can we detect gravitational waves? You see, gravity is a law that applies to this entire universe. So yeah, I do believe that there is a universal time, but it's just a difference on locality that dictates like how fast time passes by. Um, whether you're in the Andromeda galaxy or standing on the event horizon of a black hole, or it just it makes no difference. It's just all part of one universe, and the binding factor is at the quantum level, and as I said, gravity is quantum particles distorting space and time. So until next time, uh, um, this is my final video on physics, maybe. I wanted to maybe get into a discussion of consciousness, which is a big topic now among physicists, like because of the emergence of AI and how sophisticated it's getting. But that's really a complicated issue. The most preeminent physicists can't come to any real solid definitions. But there's some different thoughts on that, and maybe I could lend some, of my couch physicist insights into that. But I'm thinking about that. But anyway, thank you for listening. And if there's any more insights I can offer, like, YouTube seems to send me a lot of like physics videos, and if I see something that is very interesting or peculiar, or maybe I have an explanation for that maybe others don't, then I'll present them in another video. But I thank you so much for your time, and have a good day. Thank you. Bye bye.